Okay, so we do seem to have a good number of participants and hopefully more will join in as time progresses. So let's just start with the webinar now. Very good morning to all and welcome to the 19th edition of the Every Friday webinar series, a platform for young minds to express their ideas. My name is Architect Tushar Mandal and I'm a teaching faculty at the Periyar School of Architecture, New Delhi. Today's webinar will be discussing biomimetic architecture presented by architect Rohan Arora. So before introducing the speaker for today, I would like to honor architect Ramendra Raj Mehta, who is the mentor of our school along with his partner. He is also a former president of the Council of Architecture. We also have with us architect Prakriti Mehta, who is another supervisor for our school. Mehta sir, if you could just speak a few words to motivate us today.
Uh, Good morning, everyone. I'm extremely pleased to welcome you all for this 19th discussion in a series which started almost 5 months ago, and Tushar is the host. So my compliments to him, all the speakers who have come here, and the participants who regularly attend this, where we are making an endeavor to generate some new ideas which concern our habitat and how few of you have a response to that, to work out a solution to solve an existing, maybe long standing and long living problems which we face continuously, either in the societal level, physical development level, or at the professional level. So kind of intervention we can think of, um, and the young minds have some kind of an idea. So what we have taken upon ourselves is that we would pursue these ideas as they get generated. We would do follow-up exercises by way of maybe a short-term course on some of these thoughts, connect you to the respective government department who would be interested in understanding this new thought, and also help you with a mentor or a teacher or a professional as may be necessary to develop this idea. So that's the whole exercise, that how we can generate some new ideas to deal with some of our existing issues, or some futuristic vision which you may have, which may bring about a change in our thinking of today, or it may deal with something which we are likely to encounter in future. So that's the background of these seminars. I'm very happy to welcome you all on this 19th in the series. And I'm looking forward to each one of you coming out with a new thought, new idea, and share with all of us. And together, all of us will do something about it. Thank you very much for joining in. Thanks, Rohan, in particular, that you have come back and you bring in one more idea to be shared with all of us. Welcome once again, all the participants and speaker, and I hope you would all enjoy the presentation Rohan brings in, and also I'm looking forward to some very active discussion post-presentation. Thank you.
Thank you so much, sir. We have also been joined by architect Kamal Raj, who is the head of our school, and I welcome him as well. So now I will introduce the speaker for today's webinar, architect Rohan. Rohan completed his BArch from the Sushant School of Architecture and his MArch from the Bartlett School of Architecture, University College London. He is currently running his own practice. He has previously worked on projects such as the Southview School in Dubai and has a deep interest in computation and biophilia. Rohan is a returning speaker on the platform, having previously presented a topic on the topic of computational architecture. Today, he will be talking about biomimicry as a means to optimize design. I would request Rohan to now begin his presentation, and it's a request to all the participants to keep themselves muted for the duration of the presentation. There will be a question, answer, and discussion session after, during which you can unmute yourself and ask your questions. Thank you. Rohan, you can now begin your presentation.
Thanks Tushar for the introduction, and thank you to Mehta sir and team of Periyar School of Architecture for allowing me to present here today. So today I'll be presenting on topic of imitating nature and how we can use biomimicry as a principle for optimizing design. So let's start. So basically, what does biomimicry mean? So basically, biomimicry is basically taking inspiration from nature and how nature has evolved over the years to uh, sort of like evolve our designs. It doesn't literally mean like to how just to copy the designs in nature in terms of like the physical aspects only, or in terms of like natural aesthetics. It's about taking inspiration in terms of like how they grow and how they sort of sustain in nature and how they become so efficient and resilient. So here is the classic example of like how the kingfisher bird inspired the bullet train in Japan, and how it became more efficient through this biomimicry. So before starting, we need to know how nature does it better. Like, is it true that nature does things better than us? So basically, here's an example of like bamboo shoot. So basically, unlike man-made structures, nature has limited energy and it needs energy to grow and sustain. So all the structures in nature, just like this bamboo shoot, have very good like design, which allows them to minimize their energy usage, usage of their food to grow taller and stronger. So basically, bamboo shoot has a structure which is hollow. As you can see here, it has the whole hollow structure, and which is to connect it structurally, it has these struts in between to give it the strength. Basically, the whole design of this bamboo culm is very strong, yet very energy efficient. Um, we as humans also use hollow tube sections and everything to make our designs more efficient in terms of like we don't need to use so much steel for that. This is similar, just with like an example from the nature where they have added struts also to make it stronger. And here's another example on the right of skull of magpie. So basically, as we know, like birds need to be lightweight to basically fly. Here's an example of the magpie skull, where each membrane of the skull has layers in between and hollow gaps in between, which are also joined in between by struts, which make it very efficient and strong, and again, very lightweight. Now, this can be source of inspiration to our current structures as well. Like we have concrete structures and slabs, and basically all those structures which basically don't need to be so thick, but we can use certain this type of technology to basically lightweight and yet be strong. And below is the 3D printed model of the skull. So we have already documented all these uh, findings, but we need to like find a way to how to basically make these now. And this 3D printer section shows that we now have the ways to make it. And another principle that I found very interesting was like how trees, which we see every day in our life, have this principle called axiom of universal stress, of uniform stress, where a tree grows in such a way that it balances out all the forces around it, and the branches grow in a way that it constantly in balance. And this principle is called axiom of stress. So basically what happens is all the forces in tree are divided so that it's always in compression rather than it faces some tension. Now let's jump to history of biomimicry and architecture. So before we start, like how what we are doing currently in biomimicry and architecture, we need to know how it all started. So basically, architects and designers have continuously been inspired by nature throughout the history. They have replicated the designs and patterns found in nature for ornamentation as well as forms of the building. Here's the example one of Parthenon. So Parthenon, as you can see, as you must have studied many times, like it has aspects of golden ratio in it, where like it is based on the golden ratio which we find in nature. As you can see in the image below, like the nautilus shell also display the similar kind of golden ratio, and many other forms in nature like sunflowers and everything have like examples of golden ratio in it. So basically a monument built in 438 BC also had examples of uh, basically biomimicry, where in terms of it's not literal biomimicry as per its definition, but they have used it basically only for the aesthetics and the form. And the right is the Gloucester Cathedral, where they have uh, basically tried to create a meadow of trees in between in the wall, and they have literally just copied the aesthetics of the meadows to create a corridor speech which is highly ornamented and which looks beautiful. But both these examples show replication forms found in nature. However, biomimicry is more than that. It focuses on finding solutions that create more efficient forms rather than just copying the aesthetics. Now, here's an example by one of the genius, Leonardo da Vinci. Now, da Vinci was also an architect, painter, sculptor, and everything. But even during that time, his main source of inspiration was basically nature. He attempted to create a flying machine through by studying birds, and being a true genius, he understood the forms very well. He kept continuously sketching birds and other animals to understand how their muscles work and how basically they move, how their joints work. And he sort of successfully developed this sketch and some iterations of flying machine just by studying birds. And these findings later eventually became the model for the latest the working airplane for the Wright brothers. Now, here's an interesting story. Around the same time when Leonardo da Vinci was like studying birds to make aeroplanes, something else was happening in Europe, where Brunelleschi was like where the dome of Florence Cathedral was about to be commissioned, and a lot of architects and all were called to given that to basically award the task for the construction of this enormous dome. But the one who won was the structure was, as we all know, was Brunelleschi. So Brunelleschi dome was inspired by an eggshell. As per the famous story, Brunelleschi had no plans or any kind of drawings to present at the meeting where architects were summoned to present the idea for enormous dome of Florence Cathedral. So Brunelleschi used just an egg to give the presentation and just mounted the egg on the table and told the jury that this is how he is going to be constructing the whole dome. And initially, even though he was mocked, but his idea, uh, they found it to be very creative, because like looking into nature and its form, they found it to be very appealing. So they went ahead with Brunelleschi, even though he had no prior experience in architecture. Like he was a goldsmith and he had designed few gates, but he had no sort of like experience in terms of like actual architecture. He was sort of a newbie. And eventually Brunelleschi carried his egg-inspired design form from the beginning to the end and finished the construction of the room, which derived the form from of the upper dome from the egg. So basically, as you all know, like Florence Cathedral has two domes, and the upper dome is sort of looks like an egg only. So basically, that's where Brunelleschi got his information, sort of inspiration from, and sort of came up with this form. And then we jump to Gaudi. He was working also like on sort of like biomimicry and everything in 18th century. And Gaudi, as we all know, is like arguably one of the most famous architects to have ever existed, and was deeply inspired by nature. and used it in his architecture for both decoration and for creating architecture that is efficient. Like as we can see, this is like his one of the most famous project, and he has used basically tree-like columns here, which allowed it to be slender. And as you all know, Sagrada Familia, like which is still incomplete, sort of like it's about to be completed. It's like one of the most beautiful cathedral to ever been built, but it's also shows how efficient things can become with biomimicry, where Gaudi like considered nature to be above everything and took his information, sort of inspiration from nature and built this magnificent corridor in the dome. And like when we are talking about tree-like columns, so like here is another example of like one of the most famous structure engineer, Frey Otto. So basically, we have seen like how like people have been using these tree-like structures and like taking inspiration from them for a while. So basically, renowned structure engineer Frey Otto in 1970s experimented with branching tree-like structures as well. Now, his studies was also based on uniform distribution of stress in trees. And basically the idea was he wanted to replace traditional beams and columns in one of his projects in 1979 to these tree-like columns. And he successfully did it in a project, and it was like one of the sort of like a marvel where like he completely replaced the traditional structure with these columns and achieve large spans. And this inspired a lot of work eventually. Like we can see a lot of architects these days using these kind of structures. And eventually after Free Auto, like these structures started to become more efficient also, in terms of like now we can, through computation, we can determine like how much load is coming on each branch, and we can determine like what should be the distribution, what should be the proportion and thickness of each branch. And sort of like it helps us get closer to an actual tree and how it feels forces, rather than like just assuming that there's going to be this much stress on one branch and sort of like that. So basically the below images show like the research on the forces on each branch, and then eventually you get the thickness of the each branch. Some branch can basically act like only like connectors where it doesn't help, it takes the tension, and some branch can just distribute the loads. So this in a way is like a more better design structure than Gaudi, because he didn't have obviously like as much research to back it up, but obviously it helped him to achieve like really thin columns. But then with this sort of algorithms and everything, we can basically achieve really slender structure which are like completely any like completely efficient in terms of thickness and everything, and basically reduce our material uses significantly. Now when we are talking about like how to use biomimicry, we need to keep in mind that we basically can't use it even inefficiently also. So what do I mean by that? Like even though the forms in nature themselves are efficient, but like trees grow on themselves. Like they don't need scaffolding and they don't need any sort of foam work around it to basically cast it. They're sort of a natural phenomenon. And basically when we talk about buildings in nature, buildings that we create, we need extensive construction process to create them. And even though like there is a building in Valencia where like they have created these huge shells to basically achieve large spans, and which is a like it's been inspired by nature as shells, and it helps them achieve large spans. But if you see the building without its construction process, it's beautiful, and it's obviously like has achieved really large spans through biomimicry. But when you look at the construction process and the amount of scaffolding that this project required, then the whole process becomes inefficient. And when we talk about like how much material wastage this project must have caused initially, then we can see like it required huge amount of scaffolding to support the curve structure, and which in itself makes the structure inefficient. And this is not the idea we should be following, like when we create biomimicry. So what do I mean by creating biomimicry in efficient way? So as we saw in the previous examples, like because biomimicry is sort of like a nature's thing, we should be looking at sort of modern techniques basically to create biomimicry structures. So here is a bridge designed by Joris Larsman. It was in Amsterdam, and he sort of completed it in 2018. So basically, Joris Larsman was like a computational designer, and he basically used Softkill and all these basic digital tools to optimize the structure for the bridge. But these complex structures can't be made using traditional formwork. So then he had to come up with a new technique as well to create the bridge. And here he has created these 6-axis robot to uh, basically move on the bridge and make this bridge without any wastage. Even though like it's made out of concrete, it's not natural material, but it still keeps the idea of minimal wastage intact. And now here's another example of like shell structure. So this was a pavilion by University of Stuttgart, which was based on biomimetics. And this one is inspired by the skeleton of sea urchin. As part of the project, a robotic manufacturing platform was developed for the automated assembly and milling of pavilion's 376 bespoke hollow wood segments. So basically, nature doesn't need to make identical elements, which basically because it does everything very like sort of in a way where it's like all the patterns in nature are sort of like different and identical, just like our fingerprints and everything. So basically this structure also followed the same idea where like a lot of pieces are different, but then they used a sort of like a robotic manufacturing technique to basically assemble the whole pavilion. And basically it's like a sort of like a 3-dimensional puzzle, and they achieved a span of basically 30 meters. And when we compare it to the previous structure, which was made in concrete that we saw, then this is a much better example of biomimicry, because then it uses the material in a more efficient way, and it's sort of takes a deeper look into how biomimicry should work, rather than because when we see like a tortoise shell, it's not made of a continuous thing, even though it's like a uniform continuous joint thing, but it's made out of tiny sort of like patterns and everything, just like this sea urchin shell, where like it's made up of basically a lot of hexagons and stuff which are joined together. Basically like sort of like it takes you deep into how you should be working when it comes to biomimicry. Now, this entire project was completed within 10 working days with the help of 2 craftsmen, robots, 2 million lines of custom codes. The robots were tasked to not only mill the wood parts, but also to assemble the entire structure, which show the advanced level of control we already have in terms of robotics. And basically to achieve such kind of biomimicry, we need to like sort of like learn how to like apply it through codes and basically use computation in collaboration with it. So basically like move away from like just creating uh, like a regular construction, which would be very inefficient to create these type of structures. Now here is another example of a robotic pavilion, and this one is again inspired by some beetle shell. So in this prototype, a total of 36 individual elements were fabricated, whose geometries are based on structural principle abstracted from the beetle. Each of them has individual fiber layout, which results in material efficient load bearing system. This project was completed in 1.5 years by students and researchers with a multidisciplinary team of biologists, paleontologists, architects, engineers. And basically, this lightweight pavilion covers a span of 538 square feet. And basically, then again, when you're talking about taking inspiration from nature, like this is a wonderful project because like in its each element is sort of different based on its surrounding, what sort of force is taking. And also, like as I mentioned before, it's inspired from beetle shell in itself, like very efficient structure. So basically this, when we produce these kind of structures, we need to sort of like try to replicate the construction in nature as well, rather than just replicating the whole form. And for this medium, we have used robotics and in this particular project. And next I'll be showing you a video of this whole project, which will sort of make you realize like how efficient these structures are, like in terms of construction. I hope you can see the video.
Rohan, is there an audio as well along with this?
Yeah.
So the audio is not there, I think.
Can you hear the audio now?
Yeah, it's there.
So basically this showed like how basically we can achieve these amazing like biomimicry structures using computation. And like and as you must have seen in the video, like it takes like enormous amount of like it can't be just like a overall research on the like just like a it has to go deep inside, like how these insect one sort of like Da Vinci only had certain mediums where he could sketch and Gaudi also had like he could only go for visual aspects of it, like to replicate it. But now we have the technology to basically like sort of like document all these things when we see it, and like we have like we can work in collaboration with biologists, paleontologists to basically uh, go in deep, and we can also like work in collaboration with computational designers, and we can basically document these in a better way and like create bespoke parts of this pavilion which are actually inspired by the forms in nature. And then we can also use these two robotic manufacturing techniques to basically manufacture these, because it can be really hard basically to replicate the forms in nature, like because when we see patterns in a rose or something like that, it has so many layers and so many things attached to it, which basically makes it really difficult for us to do without making any drawings and everything. So basically, this is where like sort of the collaboration of biomimicry and digital tools come in, and which can really help us to achieve biomimicry for the upcoming years and can help us inspire to make like better structures. This is it. This is where I end my presentation. And
Okay, so thank you for the presentation, Rohan. It was pretty concise, but I think well explained. So yeah, now we are open for good question and answers and discussion. And if there's any participant who wishes to ask a question, then they can either put it in the chat or they can just simply unmute themselves and ask the questions. So is there any participant who would want to ask? Then please feel free to go ahead. Okay, so there's something in the chat. Okay, so we do have a question.
Can I say something? Can I say something?
Yes, sir. Yes, sir. Please go ahead.
Yeah, I think while you would have one or two more questions. The question I have for Rohan is that we all understand that this is what the great masters of architecture had relied on not only the form, but the structural systems which nature had offered, be it birds, animals, fish, plants, trees, whatever it may be. How do you think in the education of architecture, this thought could be inculcated? Because you made two very interesting observations you made. One was that nature doesn't do anything which is useless. You see, so optimization is actually, it's always there when nature works with its own structures or whatever creations it has. So where do you think the intervention is required in architectural education to have something which gets evolved through this biomimicry, what you say?
So basically, like I think when I was researching on Gaudi, and basically he's like huge inspiration to me, and I hope all of us. And basically, what I found out was like even for Sagrada Familia, he didn't intend to make any drawings. It's such a huge project, and your first sort of intuition is like our first intuition. Let's make a plan. Let's make a. He basically went ahead and started creating models, and sort of like when you're making models, you come up with sort of like techniques where like which are more sort of efficient, and where basically if you would have like started with a plan, you would have just given a regular straight column and everything. But when he is designing in 3D, he's basically thinking of the form, how he can basically achieve these large spans and everything. And this can be really good exercise for the students, well, like just to like start the project sort of like with materials, and like sort of how they can use it, like limited amount of material to create a beautiful project, rather than like making like drawings and everything, and basically researching on like sustainability and how we can achieve see nature, and how basically we can take examples from it. Like these are just very few examples which I could like add in the presentation. There are like examples everywhere, like sort of like sunflowers, as you can see, like they sort of orient themselves like to face the sun and everything, and we can take inspiration for solar panels, for example, for them. And like the like sort of like it can be a task in itself to basically like study nature and basically sort of like create sort of like a newer architecture, sort of like think about like how we can use that in your sort of like educational project, because then there's a lot of freedom to do it over there.
Yeah, fine. I think it's a good idea. But let me share with you a thought which comes in my mind as to how we can take on from a situation like this. When I was a student, we had a course on art. Kamal, of course, has also undergone the same scheme of things at SPA, that art was given an equal importance. And one of the important, I should say, aspects which was introduced through the teacher of art is sketching plants and trees. You see, that was an idea to tell us that how these exist, how these stand, how do they behave when there is a storm, there is a strong wind, and what form and shape it takes. So I would feel that to introduce this subject of the beauty of nature, and then of course we were to sketch animals, we were to sketch birds and all that. We had to do as a part of exercise in art. So at that time, maybe we all thought that this is all about art. But as we gradually progressed from first to second year and second to third year, we started understanding the correlation between the structural design and the forms that exist in nature, in plant, animal, fish, birds, and also the optimization of shapes. You see how bird has to fly in a wind which is maybe in opposite direction, or if it is humidity is high, what happens to it, and so on. So maybe I would have a thought that maybe we introduce or reintroduce what used to be there in some of the schools as a practice, maybe at JJ, at SPA, that we introduce this introduction to nature as a subject, and through sketching, so that you understand how the leaf withstands wind, or how a tree stands in a particular form, or the branches, as you said, and then evolve the structural system over it. But the first and foremost is understanding the natural system of architecture, or the architecture of nature. And that could be a starting point, so that some of them may just simply love it, and then work around what you say, making models and making form, and not actually drawing up plan elevations in section, but thinking holistically. So I would think that we need to introduce it at a very, very basic level, that understanding of architecture of nature.
So very good ideas, sir. Obviously, like it comes from your personal experience, and like that's how it should be. Like you should continuously draw it out so you can sort of focus on the details and everything.
Thank you, Rohan, and thank you, sir. We do have one question in the chat, which is, so Shruti asks, could you share your views on the idea that an improvement in computation power has in turn increased the complexities of biomimicry? Or is it the other way around, where in an attempt to mimic more complex natural phenomena, we have created better technologies? So which of these two do you do you weigh in your idea on?
I'll eliminate the question, and it's really a complicated one.
Yeah.
Like obviously, as you progress in terms of computation, like a lot of things come to in your mind where basically like it's really hard to do biomimicry. Like basically what we certainly miss is like, again, these structures are not like we are not like sort of like we don't have the power of like nature where we can like sort of grow tree like structures and play around at a cellular level or something like that. And these plants are basically very complex when it comes to like basically their like growth, they produce waste and they produce everything. But obviously, what computation design can do is like it can basically help you focus on like simulations, and it can help you like derive certain examples from the nature, like sort of like it's been many years like since like computation design has taken inspiration from sort of like selective growth, or like sort of Darwin's theory of like evolution, where it's sort of like it takes multiple iterations, and like it basically kills off those which are like sort of unfit, like sort of like say like if there are like two two specimens, and like which one is like sort of like stronger for the environment will like sort of move on to the next stage, and some like things like that. So basically, obviously, as you advance in computation, things will get more complex. You will sort of like start to analyze things better and everything. But in the end, like the idea is not to make things complex, or to make sort of like it's about creating efficient structures. And if like reaching into those complexities and then eventually be able to execute them like or turn them into like a piece of architecture helps us achieve efficient structure, then I think yeah, like that's how we can like collab computation. It doesn't have to, we don't have to necessarily look into complexities, like it's just a part of the process where like as we progress we will find something complications, and as we move on the next level, like when we research more we'll find new things, and that will just help us evolve the structures better and execute them better.
Good morning.
Okay. Thank you, Rohan, for the answer, and thank you, Shruti, for the question. So we also have another, I think. So Prakriti ma'am also gives in her views. She says that I feel while nature holds in it an enormous, inexhaustible source of solutions. When it comes to biomimicry and humans, we have the potential to borrow, imitate, and also create a world that is inclusive for man and animal in harmony with nature. So, what are your views as an enthusiast in biomimicry? Rohan, if you could just give in your views on this as well.
Let me take this one also.
Yeah.
Yeah, so basically, biomimicry doesn't always mean like sort of like basically creating an inclusive environment, and like, but that's also like not a bad idea. Like, it's obviously should always be an inclusive environment for like animals and everything, and it will sort of like it's we can look at it more towards like sort of like you know from a different angle of sustainability, where like an inclusive environment will help us to like sort of in nature like sort of that moves into the realm of biophilic architecture, where like sort of it attracts nature towards it. But it's certainly different from biomimicry, where biomimicry only focus on creating forms that are inspired by nature. But obviously sort of biophilic architecture can, obviously it would be lovely to have like a sort of an environment where like it sort of like also become sort of like inclusive in terms of like birds can obviously like uh, sort of like have hives and everything and create nests and everything, and plants can grow on the facade. But it's completely different from biomimicry, where like it's all about form and sort of like if you're sort of replicating a bat wing or something like that, then you don't expect plants to grow on it, or you don't expect bees to come and sit on it. So it's sort of like different. But yeah, obviously like we can obviously look into ways to combine both of them, where like it can be biophilic, bioreceptive, and yet inspired from nature in terms of like tree or something like that.
Okay. Thank you. Is there any other participant who wants to ask a question? You can unmute yourself and ask, or you can put it in the chat box if you want. Do we have another question? Uh, is there any other participant? So in the meantime, Rohan, I think I would also lead off with the question. So in the previous point, you just mentioned about three things, which are basically biomimicry, biophilia, and bioreceptive architecture, right? So and you mentioned about that we can look forward to try and combine them together. But like in your view, what do you think would be, or if you could just basically give in your views on on that amalgamation, as to do you think that there's any project that comes to your mind, or maybe any sort of an idea that comes to your mind where we can actually try and bring the three parts together? Because if we look at it in another light, I don't think the three of them are mutually exclusive. Like they're not like it's not like one of them that only one of them exists. So the three in a way need to coexist together, or should be mutually inclusive. So if you could just give your views on that.
They don't necessarily need to be like coexist, like because like biophilic architecture doesn't necessarily have to be like very efficient. Like when we're talking about bioreceptive or biophilic architecture, which is like sort of, I saw this idea where like it can be as simple as like now the houses in UK have to basically put a brick in where they can like sort of like bees can come in and live. So that's just the idea to support, but it's like they have used sort of like a conventional idea of having a brick in the house, but then they have made holes in it where like sort of bees can go and live. And basically like there's a lot of research on like how bees are essentially sort of like crucial for existence of humans also. But yeah, but while I said like they don't have to exist together, but it's also not a bad idea for them to exist together, because like in nature we see phenomena like symbiosis and everything, where like sort of when we create structures that are inspired from nature, they also have space for other microorganism or sort of organism which like sort of like come and live there. Like sort of like when we saw the shell of sort of sea urchin, it has a lot of cavities inside, a lot of space inside, and basically microorganism or maybe like little birds can go and live there. And basically when we see, a simplest example would be like we see a lot of replicas of like trees, basically where they like sort of like form the basic structure of the trees and grow plants on it, like which is another idea where like when we sort of like are talking about these tree like structures, we can basically sort of replicate the skin as well of like bark, where like sort of like it's puncturable, so like basically birds can sort of like live in it, or sort of like. And basically the whole idea of like basically for uh, if it has to be closer to nature, or if it has to be closer to biomimicry, then obviously we can like basically make it sort of like better for uh, sort of like for flora and fauna around us to also to attach to it. So and then it will be a step closer to basically biomimicry in terms of it will be actually be uh, bioreceptive and like act just like stuff in nature does.
Okay. Thank you for the answer. Uh, do we have another participant who wants to ask a question, or do we have a question already? No, so I don't think that we would be getting any more questions now. So I think we can bring the webinar to a close with this. I
Would
do.
Kamal like to say something? Would Kamal like to say something?
Kamal sir, can you do you like to say a few words?
Or, I think he was traveling. Yeah.
Yeah, can you hear me?
Yes, sir. Yes, you're audible.
Okay, so I'm somewhere, so I could not, I mean, I could see it in parts only, but it is very interesting. And this is something which I teach in SP also. And I think we have to teach our students the aspects of modern, I mean, architecture is changing, so it is more digital and more these digital means, and the technology gives us a method to create structures which were not possible earlier. So I think in our workshop and all, we should try to take some projects and tell the students to reconstruct it. So suppose we take this shell of a sea urchin, and then I tell the students to make a model of it and make the drawings of it. And in that, we will need young people like you to participate, so that these things can be taught to the people, I mean students, at undergraduate level. So these are some of my thoughts. but I have not been able to attend consistently. So that is a limitation.
No,
I
no,
was
no.
not
But I
there.
think what Kamal has said is absolutely right to dot. You see that these have to be evolved through workshops and interactions, so that they make some kind of an understanding. It brings in an understanding amongst the students of computation and biometry together.
So
It
what we
can,
can do is that we can have a workshop, and instead of creating new structures, something
yes,
which has been created, we try to replicate
understand.
it through physical model and drawings.
Yeah.
So I think that is going to be, so the mentors have to develop that first.
Yeah.
They take a couple of projects and reconstruct them and then teach it to the students.
So Rohan, you have a task at hand now.
Definitely. I'll get in touch with Tushar and you guys and
Yeah.
develop something for you.
Yes,
work with.
yes. Yeah, wonderful, wonderful presentation on the whole. Excellent.
Thank you.
Thank you, Mehta sir and Kamal sir. And I
Thank you.
think with this
Thank you.
we can bring the webinar to a close. I do thank Rohan for a wonderful presentation, and I do look forward to working with him in the future as well. I prefer maybe on a workshop, or we'll see how we can move it forward from here. So I would also like to announce that the recordings for these webinars will be made available on the YouTube channel for the Peria School of Architecture, and all future all the past webinars and the future webinars will be slowly uploaded on the channel, so you can also feel free to go and watch it there. Thank you everyone present today. Thank you for your time, and once again thanks Rohan for the presentation. Please have a good day everyone. Thank you.
Thank you.
Thank you.